Hello out there, MLOps.community coffee session podcast listeners. We have got a special third episode of the continuous training Google paper review. We're getting in deep today. I am joined by none other than David Aponte from Benevolent AI, keeping it fresh, enjoying this smooth music we're listening to.
Oh, yes.
So let's get into it, man. Let's talk. I know that this is really round two of our chat because we've done this yesterday and then I lost all connection to you and it got kind of weird at the end. But that gave us an opportunity to talk about it again and hopefully tighten things up a little bit.
That's right.
So now what are we going to be talking about? Let's recap what we talked about in the first and the second episode, and then let's jump into the third one and all the good stuff.
So I'll recap and then you dive in. So we started off this paper really kind of addressing the way that Google was approaching MLOps and in many ways setting precedent for what the definition of that is, and subtly, I guess throughout, maybe not so subtly in the paper, but communicating what they think are best practices within that space. We address things like automation. What's the point of automating everything? Because that's kind of a presupposition in a lot of their points around that. They talk about the distinctions between MLOps and DevOps, something that we've been talking about for a while now. And then we covered a lot of the major components that this paper kind of gets at, continuous integration, continuous delivery, continuous training. We talked about concept drift. And so now what we're going to get into is a little bit of a deeper dive into the actual process and how Google rates how they scored the maturity level of this process. And hopefully that gives you enough preface. For those of you who haven't listened, we encourage you to listen to the other two episodes where we really do go deep into a lot of this stuff. So
Yeah, and as always, if you have any comments or questions, feel free to reach out to us. So now let's start talking about the data science steps for ML, right? We left off at this place where, and here is my vision of how we can get through today, is talking about these data science steps in a bit more depth, then talking about maturity level 0, which it just sounds horrible. Nobody wants to be at maturity level 0. And then talking about maturity level 1 and how those differ. So without further ado, I think we can crack on. Let's talk about these data science steps, and I'll go through them and let you add whatever color you want to on top of it, David, because I know you are more of an expert in these fields. And I'm surprised, David, that you haven't mentioned anything about my sweater that I'm wearing yet. I wore it just for you.
I love that sweater, by the way. For those of you who are not seeing this, I will describe it. It is fluffy. It has frizzles of hair popping out on the side. It looks
got like
light.
A tribal design.
It has like a tribal design. It looks indigenous. It looks very light and airy. Like, he looks graceful right now. That's hopefully.
And the best part about it is I stole it from my wife. So it's starting to get cold here in Germany, and I'm grabbing whatever I can. So
do what you got to do.
That being said, let's talk about some actual useful stuff. But first, let's roll the intro.
Lights, camera, action.
Get scene. Hill, could you get me some coffee?
There's no more coffee.
No coffee? No coffee? Ah! If I can't take my coffee break, my coffee break, my coffee break. If I can't take my coffee break, something within me dies. Something within me dies. Yes, something within me dies. And scene.
I hope you enjoyed that hilariousness. David and I both were cracking up.
Yeah, we loved it.
All right. But anyway, here we go. Data science steps for machine learning. We have got the data extraction part. the data
Oh, yeah.
analysis part, the data preparation part. And what I will say is, up until this point, is where you hear people talking about how this is where 80% of the work gets done. Let's
Hmm.
jump into it a bit more. You have data
Yeah.
extraction, where you're basically deciding how you're going to collect all this data, what you're going
Hmm.
to do when you get it, like where are you going to put it, all of that part in the extraction. It's really quite simple when you think about it. You're extracting the data, figuring out then how to get it, right? And where to
Yeah.
put it.
Yeah. And usually there'll be some thought like into the different types that you need. Maybe
Mhm.
you can collect a lot of this stuff in-house. Maybe you need to reach out to someone outside of your organization. So yeah, it could be very simple, straightforward. There could be privacy concerns here. There could be all sorts of things. It may be publicly available. It may be not. Yeah.
Then we that leads us right into the next one, which is this data analysis. And here you really want to make sure, do you have the right data for solving the problem you're trying to attack, right?
Oh, that's
And
exactly. Yeah.
if you don't have it, how can you go about getting it? And going back to the extraction part, again,
Yeah, exactly.
it's that whole
Yeah, yeah,
thing. So you want to understand the data schema and the characteristics that are expected by the model, and you want to make sure that
100%.
that data is on at your fingertips. So next we can go into the data preparation, unless you had anything else you wanted to add on the data
Yeah.
analysis.
So sometimes at the data analysis step, if you have a good idea of where you want to go, you may be doing things specific for the sort of end of your pipeline. So if you know, for example, um, if you know what type of model you're using, what type of algorithm, then you can engineer your features for that. Some algorithms take care of that for you.
Mm,
So for
great
example,
point.
Cat Boost, it takes care of the encoding of the categorical features for you, the encoding of the text features. So my pre-processing for that can be a little bit different than if it was XGBoost, where it doesn't do that. So I'm going to have to do that on my own. I'm going to have to one hot encode the features, for example. And so like depending on what you're doing at this stage, you may also be already preparing and searching for specific things with your goal in mind. And then again, this is a very iterative process. Maybe even at this early stage, you try a simple baseline model if you know your problem. Maybe you do an unsupervised approach and just like see what clusters you find. So it could be very open ended. It could be all over the place. It could be very short. It could be very long. Yeah.
Well, these are great just caveats of it, right? It's not like you do one step and then the next step and the next step. It's very much like a zigzag, and
Yeah. Yeah.
maybe you're exploring with the data analysis. And you said you kind of segue into data preparation. You could be preparing the data a bit in the analysis. And
Oh
so, what
yeah.
is the
Yeah.
data preparation, right? The data preparation is when you start feature engineering it, you prepare the data, you want to see like how the model. So you want to make sure you split the data into training, validation, and test sets. And I know yesterday you caught me off guard on the question, but today you can ask it again and I'll give you the right answer because I remember from yesterday. But the training, validating, and test sets, I think, are very important with this. And then the feature engineering is another huge one, right? And so this is the preparation part. You want to
Mhm.
get all that data ready. And this is also where you'll hear, like, you clean it and you hear a lot of people saying, this is like 80% of my time to make
Yeah.
sure that the data is clean.
Yeah, yeah, 100%. You mentioned about first off, that's awesome that you're understanding cross validation, right? And the general gist of it is that your test set is to be as close to the real situation as possible. This is your live environment, right? And again, going back to like something we talked about in the past, a model should be able to generalize well. It should be able to perform well on new instances of data, not the things that it memorized or it learned during the training time. And so at this stage, another important thing to keep in mind is consistency between these different sets. So whatever features you have at training time, the schema needs to be the same at live inference time. So when you're making real-time predictions through your prediction service, they have to be the same, right? The format of the features, the same number of columns that were used during training time. So a feature store is probably going to be part of this, like, this, it's going to be used at this stage as well. During that extraction, maybe you're adding new sources to that your store. Maybe you're even doing a bunch of experiments with those features, trying them out. Because one like little side note, but a feature could essentially be a model on its own. Like you could use a feature to actually make a prediction. And that's what good features should do that anyway. But yeah, so like long story short, you can do a bunch of that. You could prepare it, massage it, run feature engineering jobs to develop new combinations of them, maybe store them, and then run models on them. So having consistency at this stage is really difficult because it's kind of all over the place. So I think this is actually a good, like, because this is, like you mentioned, you never do it one step at a time. It's like one step, then you go back, and then maybe you jump ahead, and it's like kind of all over the place. Just think about the challenges from an MLOps perspective of like having operations run smoothly for that, right? Like that's a tough thing to do, to allow people to freely experiment but not hamper their creativity, not hamper it with so much process, which is what a lot of MLOps is in my mind. It's like
Mm.
it's not just like one thing. It's not an object. It's a set of practices, I guess. But yeah, so at this step, I think it's really challenging to really bring reproducibility here. But in the paper, they're arguing for some ways to make that a little bit easier.
Mm. And I think that there's that question of the how to keep it so that you can research and iterate quickly, right? And find something, and then how to keep it also so you can go back and reproduce it. And so I think that's a huge point. But let's keep cracking on. Let's move on to the model training phase now.
Hmm.
This is what most people think of, I think, when they think about machine learning.
Yeah, machine learning. Yeah.
And so maybe we don't need to go into too much depth on this, but this is where you're, doing some hyperparameter tuning. You also you're changing some weights and biases,
Ooh,
potentially
love it.
using that actual tool, weights and biases. And you're really trying to get a trained model, right? That's like the output here.
Yeah, definitely. The output of this is going to be model art or training artifacts.
Mhm.
So it could be the serialized model weights itself, but it could also be that and maybe the arguments that were passed in at runtime. In one of my models that I work on, that's something I do because those parameters we actually use elsewhere, and so we need to pickle them as well. What else can you get at this? That you can get us at the output of this, you could push it to a model registry. So this is, you could
Oh,
put it in a
nice. Yep.
centralized store, right? And maybe you're adding metadata at this step too. Where the runtime environment, where the a path to the artifacts,
Data
what
versioning.
a version, yeah, what features were used at training time, etc.
Cool. So once you've completed that and you're pretty happy with your model, then you're going to go to this whole evaluation process, right? So you have the model trained, or you have many different models trained, and then you validate them. You make sure that they are good to go. And you want to see, like, what's the quality here? What is the what are the metrics you're looking at, and how do those
Hmm.
measure up with what the model is doing and how it's
Yeah,
doing? And so a lot of people like to say accuracy here, but I know that I've also heard a lot of people say accuracy is not the most important thing. There's other
yeah.
metrics that you want to be looking at. Maybe you can dive into the other metrics that we can look at here too.
Sure. Yeah, I guess, well, it definitely depends on the problem that you're looking at, but what it sounds like that was getting at is the difference between like model metrics and like maybe business metrics. So one thing that is really important is that you have a way to relate these maybe low level model metrics like ROC, or your training loss or whatever it is that you're looking at, accuracy, recall. But that's like a model metric, and that could be easily gamed, in many ways. So what really is more important is like your business metrics. So what about like the click-through rate or something like that? So, and it's really hard, I will say this, it's hard to make that link sometimes, and because maybe the data is sparse and it's not that reliable, whatever. Or but yeah, it could be just yeah, I think I answered that, sorry.
So now we get to serve it up. And we've
Serve it
talked
up.
quite a bit about serving. but it's always
Yeah.
good to go into because I think this is one of the main things that are blocking a lot of people when they're trying to get their machine learning models out into production, right? How to serve it,
Yeah.
what tools am I going to use when I serve it, what is serving. And I know that in the past, I used to call it deploy. That sounds like a
Yeah.
really cool name for
I
serving.
think that's typically what we mean when we say deployment, right? You're serving it. It's like just an application that you're, making available to the real world.
Yep. And so we talked about this in a past coffee session on all the
Yeah.
different
Yeah. Yeah.
ways that you can serve it, right? You can embed it into an actual hardware, and that would be for like a autonomous vehicle or something that is out on the edge that you want the model making those predictions right there. You can also have it be a batch system if it's not necessarily needed to do real time. And then the other one
Hmm.
was it was
A REST API. So it's the tip. So serving it as like a typical prediction service. And then yeah, there's a lot of ways I've seen this like kind of like expressed. Like I've seen function as a service, or like yeah, I don't know. Anyways, but the point is, yeah, you're gonna typically have like a little service that can serve online predictions. It's usually gonna be working in. I mean, yeah, I don't think you. I mean, you could have a REST API that's not working in real time. Like in fact, that's actually something that we do, but it typically is just going to be an endpoint that you can interact with over a network. So I think that's one way you can
mm,
expose those models, right, as a resource. Another, and then you mentioned the other two. So yeah,
nice. So the last thing that we'll say is what is commonly referred to as the day two operations, right? So once it's actually out, making sure that it is doing what it said it would be doing when you trained it, making sure that it is not, there's no drift that's happening, there's no bugs that have just snuck in there. And so you have your monitoring piece, which is huge. And we are both big proponents of monitoring. And it's also one of these things that is so important, right? It's just so important.
yeah, yeah. There's actually even a lot of cool stuff happening within this space. If we're gonna post a link to this, but there was this paper on Medium, or not paper, article on Medium, titled "ML Powered Automatic Model Monitoring," and it linked me to this archive paper where there's an someone has come up with an unsupervised approach to addressing concept drift. So it's called SAM, stands for Streaming System for Automatic Model Monitoring, and it basically allows you to just detect it, and I guess it trigger an event, maybe retraining or something along those lines. But yeah, so what's interesting to me about this is that there's already like smart intelligent solutions that are happening at this stage, right? Because it's like one of those things that an error can be very subtle, maybe very hard, easy to miss. And so that's typically where machine learning, in my opinion, shines. It's like when you're trying to find those patterns that aren't really visible to the human eye, and maybe you have a lot of it. So if you have a lot of data on your model, like let's say it's getting a lot of traffic, it's making a lot of predictions, then you have a lot of essentially information to work with, and you can utilize that to then do data science and apply something like this. And so what's interesting is that like you're now using ML for the ML in some ways
Mhm.
throughout the process, which is like very cool.
Yeah, and if you want to check out more on monitoring, we've talked about it a bunch. I know that we had a great talk with Lena, and she talked about all the different ways that bugs were like she found bugs in her models when she was working at Zalando, a huge company in Germany. And then also Flavio had a great war story when he talked about how one of his recommender engines was recommending the same product for 18 days straight. And so anyone that was on this web page
Rough,
for 18
rough.
days straight saw this product being recommended. I don't know the details, but I think it would be hilarious if it was like a I just think like I'm looking for shoes and I get recommended a tutu. So
Yo, man, it's funny, but like that they probably lost money, and
that's
it
what he
probably
said.
hurt.
Yeah, he
Yeah.
said they over hundreds of thousands of euros.
Oh,
Yeah, for sure.
dude.
For sure because that's
High
what
stakes,
happens.
man.
Mhm.
Yeah, that's what happens. Yeah, that's exactly right. So this is why it's important, man. MLOps is really about addressing some of these things. Again, there's a lot of practical import to this, which I love, versus a lot of the theory, which is cool. Theory is cool, but love the practice stuff. Love the
Well,
practice.
let's talk about this paper a bit. And what Google is saying, right, is the level of automation that you have on all of these different steps determines your maturity. And
Mhm.
so when we go through these different maturity levels, just keep that in mind in how they architect the different kinds of maturity vision that they have. So we can go into the first or level 0, I guess,
Yeah.
and might be better if we share our screen in this
Yeah. Let
moment
me
to
starting the yes. Oh, but it said it will stop the music. Is
it'll
that cool?
stop my screen share. Oh no.
Oh man, why are you
Well,
doing
I
this to
can
us?
we
Can
can
you screen share? Just
I
the
can. Yeah, I can
do
screen
the just the
share.
that image. We're gonna take a look at the figure 2 in the article MLOps continuous delivery and automation pipelines and machine learning. You can check out figure 2, which is titled Manual Steps to Serve the Model as a Prediction Service. So that's what we're going to be working off of. So while you're pulling that up, I'm going to kind of get us ready for that. Sound good? Cool. All right. So this process is typically going to be, again, as they described, where you have a lot of data scientists working. You have a lot of researchers, trying out a lot of different ideas. Both data scientists and machine learning researchers. Maybe they're, depending on the problem domain, they're trying to build state of the art models. Maybe not just like a practical model, but actually like state of the art, pushing the limits. And a lot of this process is going to be very manual. Yep. Maybe we could zoom in a little bit.
Okay.
Oh yeah, yeah. And they say this is very manual, typically script driven. Maybe writing a one-off script, or it's going to be in a notebook. So it's not really, it's not like prepackaged code or whatever. It's just going to be kind of a little bit here, a little bit there. Typically, going to be a disconnect between the work that this team does and then the operations team. So they may not know too much about what the SREs are doing, or if you have a DevOps team or an infra team, they're focusing on their stuff. They're not releasing often. New prediction services are not being released that often because there's not really a need to. There's typically no continuous integration, no continuous delivery. There's no need to automatically integrate new stuff and then release it right away. And then another interesting point is that here, what you're deploying is just a prediction service. So just trained model versus what we're going to talk about in level 1, an entire pipeline. So a pipeline that could actually reproduce that model. So here
And
at
there
this stage,
is a clear distinction here between the machine
yeah,
learning part and the ops part, right?
yeah,
They make it
yeah, there's a
very
big
clear.
separation there. Yeah,
Yeah.
and again, another thing you should notice is that there's the experimental and dev environment, and
Mhm.
then there's the production environment, and all that you have is actually all in experimental, right? There's nothing deployed in your production environment except for a model. And so again, there's some challenges that they think come up when you do that. But if this is not a problem for your domain, I think this does not mean that it's bad. Okay, you're not doing continuous delivery. That's okay. If you're manually releasing a new prediction service, that's fine. Again, this may solve a lot of problems. So there's no need to
Well, there
pick
is
at it.
one
But
challenge that they mentioned that I find interesting, and we kind of touched on this yesterday, is the models generally break, they said, when they're deployed into the real world like this.
yeah,
And we couldn't really figure out why they decided on that, but I guess it's
I
Google and they
think
probably had some experience with it.
it Yeah, probably. And I think what they're thinking about is this idea that your model should be able to adapt to the real world and respond to it. And if you are not frequently delivering or releasing new versions of that model, then it's going to break easily because it's not being updated with the changing world. So it's just gonna at some point break. And that
That makes
again, that's what
sense.
they say. Typically, here you're not going to be. Excuse me, you're not going to be releasing new models or retraining that often. Maybe once in a blue, and that's why they're going to fail to adapt to the environment. And so that's to me, I'm like, again, if you don't really have that problem, if your world isn't changing that often, or if the time, again, your time to release is like dependent upon some of these other things that forces you not to retrain for whatever reason. And I think we had an example of that with someone in the healthcare industry. There was like a blog post or something, if I recall. Do you remember anything
Yeah.
about that,
Yeah, they
Demetrius?
were saying that they didn't. I think it was somebody that I talked to like a year
Yeah.
ago, and they were saying that they didn't actually deploy that many models. And when they did deploy them, they had to keep in mind that the model probably wouldn't be changed, or they wouldn't
Mm,
deploy another model for another 18 months. And so when you think of it that way, yeah, it's fine if you do everything by hand because you're only deploying one every 18 months. But I
yeah.
imagine that they also had, and I didn't ask them, but they probably also had to really rigorously test this model and figure out which one was the one that they were going to get into production, right? And
I would hope
so
so. Yeah.
that they potentially were needing a lot more automation on.
Mm. Yeah, see that's the thing, and like automation makes sense when you start like looking at like, okay, we're doing the same thing over and over again. It's There's a lot of steps that we're taking. It's if there's gaps in between those steps, but again, we know exactly what we need to do over and over again. That to me is like a good cue for like automating that.
Yeah.
There's a process. That's essentially what like an algorithm is, just a recipe to do some work.
Hmm.
So and that if you have a regular or common pattern or recipe, so to speak, that's a good like kind of I guess I don't know right there if I'm saying it right, but it's just a to me a good signal to think about automating that process to build a solution for that. So at this stage, I'm going to just kind of keep on going.
Hmm.
One thing that they say can help improve this process, because again, they're looking at it as actually like slow to respond to what they're in their minds is a really important challenge, is like that your environment's changing all the time, so you need to retrain. So
Yeah.
let's assume that that's what we're dealing with now. And if that's what you're dealing with, then this can actually be a little bit challenging because you may have to do so much stuff from scratch every time. And that's cool up to a certain point, but it's also error prone. And as
Hmm.
we've learned, there can be really big costs associated with a small, stupid bug. So one thing that you can help to minimize that is to actively monitor the quality of your model in production. So that's the first step. Just start. Okay, you only have one prediction service, but you should be knowing everything that's going on in that prediction service for those 18 months, right? And what you should do is check for degradation. Is it changing performance in any way? Any patterns there? Is there any staleness like over time? Do you notice that it just again? I think it's the same thing as like what we talked about earlier with concept drift, but
Yeah.
what you should do is use these as cues to trigger new experimentation runs, orchestrated experimentation runs, and then retrain on the new and latest data. So that's the first thing you can do. Monitor, start recording events, and use those as cues to then start over again, the process. So you can go back to the data extraction point. Maybe you realize that one of those data sources is corrupt. Okay, so we need to repull, maybe point to a different version of that API if that's how it's exposed. That's one thing. Two, frequently retrain your production models. They think that if you're capturing this evolving and emerging patterns, then the only way to really deal with that is to retrain on the most recent data. There's been some good criticisms about this though, because it does make sense to me that a model shouldn't always. I mean, again, depending on what your domain is, it shouldn't have to be retrained so much. There should be some level of generalizability. It should be capable of making predictions for new instances of data. And if it's not like consistently in your solution set is just to keep you training, there may be something wrong there in my mind, and I think Laszlo, shout out to Laszlo, brought this up in a thread a little while ago, and it was a good point. Like again, it's a good like again, it sounds cool, just retrain, but that may not make sense for a lot of people.
Well, and do you think that if it was just retraining continuously, then eventually you would get to a point where you say, man, we got to automate some of this? Because if you're
E-
retraining all the
e-
time and then you're trying
yeah,
to put it out into
exactly.
production.
Yeah, see, that's where I'm saying it's like you kind of it naturally leads to like, oh, we should automate this type of thing, you know. But never starting there
Yep.
is a good idea in my mind because you just never know. That's over engineering. That's a classic example of over engineering.
Yeah, we
You
talked a little
automate,
bit about what over engineering was yesterday, but I think it would be good to mention that
yeah.
again.
Well, I guess I don't know how other people would define it, but I know this is something I do myself. Is where I'll like try to build a lot of stuff for just like a small problem. And like I don't know, it could be when I think it's I forget who says this, but when building a software system or machine learning system, and I'm thinking about the design and how I'm architecting it, I the things that I'm trying to get right early on, the things I wish I got right early on, is what people I forget that someone said is architecture. The stuff that you wish you got right at the very beginning, because it's so important to everything that you do.
That
And
foundation.
yeah, yeah. And the problem is when you're researching a lot and your domain is very research driven, it can be dangerous to build, and then things change. There was a meme a while ago on a bridge that was built for some river, and the river just completely like moved, and so it's just like a pointless bridge living existing there. That's over engineering, and it's like building a huge solution to a problem that may be changing, and this is something now I don't want to say I struggle with, but it's something that I have to keep in mind as I'm working. Okay,
Okay,
I
so
could build this cool thing for this, but I'm not. I'm just going to run it in a notebook just to test this hypothesis.
yeah, yeah, exactly. Being a little less ambitious with your skills in a way, or just being realistic.
I think it's being more like better with your time. Like you can go off on a tangent building this crazy thing, and then it like okay, it's the coolest machine ever, but it who cares? It's like that if it doesn't solve the problem or for whatever reason things change, then it's kind of a moot point. But anyways, that's over engineering. Hopefully, you guys are familiar with that notion and can relate to any engineers out there. But yeah, another thing you could do to minimize errors in a manual process is continuously experiment with new implementations. So try new architectures, try new parameters, try new data sources, experiment, and then go back to the drawing board and keep going. And the reason why that you should do that is, again, it's just pushing the bounds of the performance. And if you're running an orchestrated experiment, which is kind of what they're saying you should do, you are able to actually continuously do that. So it actually enables more experimentation, more ideas that you could try out. And the quicker you could do that, the quicker you could find the best ideas, and the quicker then I guess you could take those best ideas into production and actually making real value for users.
Awesome. So now I've already skipped ahead to
Oh, good.
the next maturity level that they say this is maturity level 1. And I
Yep.
know that when I looked at it the first time, I was like, what is this labyrinth that is in front of me? Because it just went from being a very simple diagram to like a crazy, insanely complicated diagram where there's lines going over here and going over there. And then this line connects to that line. It's like shoots and ladders in a way.
Yeah,
Let's
there's a
go
lot
over
going
what is
on here.
happening here. I think we can
So
start
first,
from left to right.
what this is like a development of the first one, and what you're doing now is automating that training pipeline. So if you go, we don't have to go back up, but if you look at the manual process, the training pipeline, now you're trying to automate that. So you're automating the data validation, data preparation, model training, model validation, right? You were doing that hopefully in like
Mhm.
one pipeline or a couple of pipelines, and you continuously integrate it into your source code. You're continuously delivering it, and then the result of that pipeline being run is a trained model that then is going to be put in some registry, gets loaded into a prediction service, and that service gets actively performed, performed. Sorry, you're monitoring the performance,
Mhm.
and then you're re-triggering not just automatically re-triggering the entire pipeline. So you're running again in an automated fashion data extraction, data validation, data preparation, et cetera, to then produce another model. So the difference between these two things is that now, instead of having this like just like manual process all in your experimental environment, now you have an orchestrated process in your experimental environment and in your production environment.
Well,
Do
this
you
is a
see
good
that?
point that there is a clear distinction here again. of the experimental part and the staging or production part, and how the difference now that you can see all of this stuff is there now for the production. So it's a huge difference when you compare it with what we were doing manually, and you had only one piece that was actually in production. But now you've got all of this and it's automatically being re-triggered, and you go through this whole pipeline again. So a
Yeah.
few things that they decided to add in this that aren't in the first one. One
Yeah.
that jumps out at me is, yeah, there's a feature store. The second one
Yeah.
is now there's metadata store also. And up here you have a source repository and source code, which I don't believe they had in that first one. The model analysis, I think they had that in the first one, or did they not? I can't
There
remember.
is no, yeah, I don't see the source code, but I think it could be assumed. But yeah, go ahead. Sorry.
No, that was it. That was the idea there, the differences that you'll see. And so I
Let's
really like,
describe it.
yeah, the high level here is that you're doing two different things, right? Like, but this one is automated. This one down below, the automated pipeline, when you get some kind of trigger, whatever that trigger is, and you can go into that a bit more, David,
Yeah.
with
Yeah.
what the triggers can be, then it just does it for you. It re-automates, or it uh,
Runs. Yeah.
runs all of this stuff that's going through,
Yeah.
and then it goes back and it does that whole circle again. And up here on the other side of it, the experimentation side, you've got this data analysis, and here is where you get what they call, right here, it's orchestrated experiment. So can you break down what that means for us?
Yeah. So an orchestrated experiment is essentially just a pipeline. So I don't this even though there's a little later we'll see a little bias towards Kubeflow. I think this could just be any pipelining tool. So whatever pipelining tool of your of choice. Instead of just deploying the output of that into production, you're actually deploying that entire pipeline into production. And so that's one big difference here. So that pipeline so all right in your experimental environment, right, you have your orchestrated experiment. What that is you do your data analysis, as you can see at the beginning, and you pass whatever data you're working with into this pipeline, and the output of this pipeline is source code. So it's something that it can live in a repository, right? And the reason why that's nice is that, like, one, there's all the nice benefits of Git and source control. You get a lot of niceties, especially if you're using something like GitLab, where you also get continuous integration and continuous delivery through their pipelines. But anyway, so you then have this source code. Maybe you need to compile some stuff because maybe there's some packages that need to be released, whatever, some stuff that needs to be deployed. You push that into your prod environment so it's available there. And what that process does when you run it is it produces a trained artifact that is going to be pushed to some model registry, right? And then that basically gets loaded. A unique model gets loaded into a serving environment. You see that continuous delivery serving, and what that produces is a prediction service. But you'll notice that, let's say you're monitoring it. So look at the monitoring, right? Let's say you're getting your results from your pipeline. Performance starts degrading. Boom, that's your trigger. Once it starts degrading, I want you to then go to the feature store, pull the latest, freshest data, and then rerun that orchestrated experiment to then produce another prediction service.
So
So
one thing that I just got a little bit confused on right now, real quick, is feature store. So feature store has three different arrows coming from it, right? One is this, what you just mentioned, rerun, pull the latest data, and then go retrain. But it also goes back to the prediction service. Why would that be?
So you're going to use the feature store to serve data for real time and for offline, or real time and offline use cases. So this is one of the nice things about a feature store is if it's all like, if its job is to do that for both environments, then it could, it could also be responsible for making sure that they're consistent between both environments.
Uh,
And that's what you want to, you want to avoid training and serving skew. So the data that you're using at training time in your experimental stuff should be the same as what you pass in at prediction time. The only difference is it's a lot less. Like,
uh,
maybe like one or two examples, right? And then you need to fill in those features that are missing, because maybe what you have, the original features that your prediction service is getting is like, I don't know, location or something like that. Like, but it then needs to be supplemented with things that are not available in that moment. So where does it get it from? It needs to get it from the feature store, but it needs to get it a little bit differently from the way that you would do it in that offline extraction. So you see how there's the feature store arrow up to the offline
Yep.
extraction? Like the offline extraction, I'm probably not going to get like one or two rows of data. I'm probably going to get a lot of data, maybe 1,000,000 rows of data. And that's like pretty standard, right? I'm getting all this data. And so latency there isn't a huge concern. So probably going to be serving it from a different sort of database than the database that will be serving it in real time. The database that's serving it in real time, typically going to be like some NoSQL database, maybe like something like Cassandra or Hive, something that you can have quick reads from. And that service, the feature store, will also be responsible for making sure that it gets to that service. And did I answer that a little
Yeah,
bit?
that's super interesting, and I feel like it's clicking a lot more today, so we're doing something right, because yesterday I
Hey,
was struggling to get through it. But
nice.
what I would love to hear, because I know you've been doing a bit of architecting yourself, what does this look like as an architecture, right? Like, how does the data move from one place to another? You're talking
Mm,
about a database like Cassandra on the serving side, but then
mhm.
on the offline side, it could be a different database that doesn't need
Like a
that.
relational database, so like a SQL database, maybe.
Cool. So what then, like, and then you're using Kafka to make sure the data goes to all these places.
If you
And
have like millions of messages, then yes. If you have like maybe in the thousands, I would use something like RabbitMQ.
Mhm.
Or if you have even less than that, and you also want to utilize caching capabilities, use something like Redis.
Redis,
So
okay.
but I don't know, I think the only probably area where I could see that being helpful is the trigger part. So an event, if you have some sort of events that you need to capture, that event will then be a trigger. So like that event will, let's say a user logs in, that's an event, right? Or another event could be the performance degrades. And those events will typically be things that so that it's a little bit different from like your request response architecture. This is more of like something happens. I'm not going to directly, like, the person who needs that doesn't really need to know about it right now. So what you'll do is you'll publish that to like some queue, some central place, and then a subscriber will subscribe to that topic, like that specific event that they want information about. But why that's important is that there's decoupling. So the publisher or that's producing this event data and a subscriber to that event data. Let's say you have like a monitoring service that's subscribed to that event of Performance Live.
Mhm.
It is going to be like getting it not directly from the event, but from something in the middle that is basically separating them. And that's typically how Kafka looks. If you look at any architecture with like Kafka in it, or even PubSub, there's different models here, and I sometimes they all kind of sound the same to me, like message passing, publisher, subscriber, consumer, producer. There's lots of
Well,
different
so
words for this.
out of that, so it's like, okay, you have some kind of feature store there that can be anything from open source like Feast or Logical Clocks to, I think we talked to Venkata at Scribble Data, or we've also talked to Kevin at Tecton.
Tecton, yep.
We've got, then you're going up from the feature store, right? You have data analysis and the orchestrated experimentation happening. Is that going on in a Jupyter notebook? What does that look like?
It could, if you have the ability to do that. So like I think you could have that with kubeflow fairing. So kubeflow fairing allows you to build notebooks and pipelines, and then um, basically, yeah, use kubeflow pipelines, but through a notebook.
And
So
another,
you could, but yeah, go ahead.
sorry, go ahead.
No, I was just gonna say, or this could be an airflow DAG.
That's what I was going to
Uh,
ask.
yeah,
Yeah.
it could be an airflow DAG, or this could be an Argo DAG, or this
Mhm.
could be a Dagster. This could be anything,
Dagster.
or even better, something super simple as make files. So shout out to all you guys who like make files. But yeah, you could create a DAG using a make file and run even a map reduce job using make files. So you can, if you're
Interesting.
not familiar, Demetrios, it's a very common software, but it's like a simple tool that pretty much has been around for a while. But you could do complicated things with that. So again, there's a lot of things that can accomplish this orchestration, but some are more specialized for one Kubernetes, and some are specialized for, I guess, machine learning workflows.
Well, inside
Others
of this, each one of these steps has their own tool also, like the data validation. Are you using
could be its own.
special tools for that?
You could, or you could, write your own validation checks.
Mhm.
So it could be something like checking the schema, the range of values, data types. Is there missingness? Data preparation. Again, that's just maybe a pipeline to process that. So maybe there is something more involved, like maybe you're using Spark or Apache Beam or something like that to
So,
process or prepare that.
real quick, just on the data preparation, you said that there's a pipeline to process that. So, there's a pipeline inside of this pipeline, or
There
potentially
could be.
various pipelines.
I think, yeah, there could be.
Mhm.
It could be something as simple as just like scaling the features. So like
Okay.
literally applying one function, and all it's doing is changing like it's preparing your data for the model. So no, it could be very simple, or it could be very complicated. But it's an orchestrated. And what you're doing this anyway, if you're doing a manual process, this is just putting it into one thing. If that makes
Uh-huh.
sense, and you could run it all together.
Okay, I see. So then model training, we know quite a bit of tools around that. And this is where, again, you would be using Jupyter notebooks. I know in the Slack, there's been a lot of heat recently of
Mm,
people saying you would never take a Jupyter notebook to production, or like avoid using Jupyter notebooks whenever you can.
mm,
But
mm.
this is where we were talking about, like the model training is where you would use a tool like weights and biases and
Mm.
ML flow. And is this where you get DVC also coming into the picture?
DVC would be more around the data validation, maybe or
Okay.
even the, I guess, extraction. Not that familiar with DVC, but yeah, like things like, like it's more around the data, version control for data, as far as that's how I understand DVC.
Uh-huh. Okay.
Um,
So then
but
the
let's one thing
sorry.
before we even move further. I think one thing that would be great to characterize this actual process. Like there's some characteristics here that they think make it unique. So one
Okay. Yeah.
is the ability to rapidly experiment, because you have basically you have a link between the experimental environment and the production environment. So you essentially could test ideas quicker in this sort of view. Two, you actually can do continuous training if you have it set up this way, right? And if you have it automatically trained using the freshest data, maybe with some trigger, you can automatically retrain your models in a continuous fashion. So this would enable continuous training versus level zero. You really couldn't do that. You would have to kind of, again, I guess you could automate it, but that would be what this does. A really great point, which I really appreciated, was what they call experimental operational symmetry. So the pipeline implementation that is used in the development or the experimental environment is going to be used in the pre-production and the production environment. So this is a key aspect of MLOps practices, which is unifying DevOps. This is something that you would want in DevOps. There should be symmetry between these two environments. And yeah, does that make sense, Demetrius? Like this, like there's a, no.
I didn't
So
really understand that part. Break it down for me
it's okay.
slower.
Yeah. So the experimental pipeline is what's above. You see that it says right there,
Yep.
experimental. So you're
Yep.
doing some data
Got that.
analysis and orchestrated experiment. The operational pipeline is what they see as the ops, right? The
Mm.
deployment pipeline. And what makes sense in both, or sorry, not what makes sense. What's the same in both environments? If you see that there's that automated pipeline,
Yep.
again, it has the same steps. And what that's what they're saying is like just symmetrical, right?
Yeah.
They're the
Okay.
same in both environments. And this is important because consistency is you can actually have a consistent like set of outputs if you're doing it that way, versus like
Mm.
you have one process in your dev environment and a different one in your test environment. That's typically not good. Okay. Another really nice feature about this, or it's what makes it distinct, is if you have modularized code. And what they mean by that is, and this is very Kubeflow pipelines, but you want to construct your pipeline and try to build it in such a way where each component could somehow be reusable, somehow can be composed into other functions. So let's say that data extraction component, maybe that's also used in other systems, and another team could leverage that if they wanted to, instead of them building the same one from scratch. So here, while like your analysis and all that stuff will maybe exist in a notebook, the actual code for doing a lot of this stuff is going to exist in some component, which is going to be a container. So what they argue is you should containerize each component, and there's some nice things that come with that. I talked about this in an article on Airflow, and the gist of it is that you want to decouple your execution environment from your runtime environment. Which, let's say if you're using Airflow, you could do with the Kubernetes pod operator, which just runs everything that you need in its own pod with its own runtime, dependencies, etc. And then what it also does, if you're using containers, is it actually makes it more reproducible for deployment. And containers are great for reproducibility. You could share images, you could build on top of images. And one second. And yeah, so another cool thing is that it makes them loosely coupled. If you can isolate one from the other, you could release them independently. They could each have different sets of concerns, different languages. Maybe one has Scala in it, one has some C++ code, some has some Python. So these are like kind of the niceties of having, you know, a modularized pipeline. I know that you can definitely do this with Keyflow pipelines. That's why I say this is exactly what Keyflow pipelines allows you to do. For Airflow, you can achieve some of these things using certain tools that make it workable on Kubernetes. But for other tools, I'm sure it's probably going to be somewhat similar. Like most tools that I see now allow you to work with an image, a Docker image, and if not use a pre-built one, you could have a custom one. And you could push them to some registry and connect them to that tool so that you could use your own custom images. And this is actually really nice, especially if you have your own custom models, custom dependencies, etc. How about you? What about you? What do you think are some other the characteristics of this pipeline, or sorry, this level of maturity?
Well, what you see is the idea of like continuous delivery happening, right? Like you can take the whole pipeline in production and it's automatically retriggering it and it's going around and it's creating this loop so that you can iterate on things much quicker. And so I think that that's awesome. I also know that you don't exactly do that. You have a little stop gate, right? Like i- if correct me if I'm wrong, where you're working, you will get it retrained automatically, but then before it goes out, you say, wait, let's see which one we want. Or is that on the orchestration experimentation side?
So like you're saying like trying different things and seeing which one you want. That probably would be the experimental side, if I'm
Mm.
understanding correctly. So
Yeah.
that you would try out a lot of maybe different combinations of data, different combinations of modeling, not like in the live system that will be serving the output of the experimental pipelines.
Hmm. So
So if
for
I
this, then the whole continuous delivery part is uh it's like a godsend, right? Because you can just automatically retrain it. You get the model. It keeps it from drifting, right? Or you don't have as much drift because hopefully you catch it when you're monitoring it, and then
yeah,
it
yeah, hopefully.
retrains, it retriggers it to retrain it on new data. And so that's definitely one that I was looking at. And then you have pipeline deployment here, right? Like
Yeah,
that's huge. If you look at the part where it's the ML goes into the ops part, you're deploying a whole pipeline, right?
yeah,
And it's not
exactly.
just this service that you had on the other
Hmm.
diagram. So that's huge in so many ways. I know that you've got some thoughts on why that is so interesting.
Yeah. So one is, let's say you need consistency between, like, it's a challenge that I've seen. There's a difference. There's some sort of disconnect between the training environment and your serving environment. If you're deploying the entire pipeline, then whenever something changes, you don't have to kind of go back and manually do these steps. You could
Mm.
rerun all of the things that you did anyway manually, but in an orchestrated fashion, so all at the same time working together to then produce that. And I guess why this is nice is one, especially if you have a feature store, is it helps you deal with some of those challenges that I've been saying a lot, like training serving skew. If you need to constantly update your model, concept drift, or just in general being able to like test a new idea quickly. If that's really important to you, then deploying an entire pipeline makes sense because it enables you to reproduce not just one step of that, but everything that was required to produce that step. And that's what I think is really important. There's, again, if you're that needs to be the same between your experimental and your production environment. When there's a disconnect there, lots of bad things happen. Bad things happen when you're not consistent between those two places.
Well, let's talk a bit more about the additional components that you have in this diagram
Yeah.
and
So
not in that first one.
we mentioned that some nice things that are different here. One is that you're adding data and model validation. So you're now automatically validating your data and your model. So maybe you did this anyway. Maybe model validation was happening on like a holdout set, but now this is part of your orchestrated experiment. So you're doing it in sync. So now what this looks like is you're checking in your data validation stuff for things like data schema skews. So, is there any anomaly going on? Is there any outliers? Data value skews, for example, are the statistical properties of your features and your target changing? Is there drift going on? And model validation, it's going to be similar to the offline validation step. But what you're going to do is producing metrics, right, on some holdout set to see how it's doing, comparing them maybe to previous values, a baseline. You're looking to see if anything has changed. Is there nuances there between different like slices of the data? And here, hopefully, what you're also doing is testing the environment as well. Make sure that you can load your binary into the serving environment. Make sure you have enough resources for that model and whatever data is going to get in there. And so these are now new things that are now orchestrated as well. So now you have orchestrated validation alongside the typical training, et cetera, et cetera.
Yeah, and then you also have the feature store, which I think we got into a
Oh,
bit
yeah.
earlier. I think we touched on that, but it is such a crucial part of this, right? Like
Yeah.
what makes a feature store so interesting when you're at this level of automation?
Well, it solves a lot of common problems. And some, can you hear me okay, by the way?
Yep.
I think my computer froze, so just a heads up. Um, and yeah, what I'll say is this: that it deals with a lot of the challenges around the data. You mentioned earlier at the very beginning that 80% of a data scientist's time is going to be working with data and just dealing with the challenges of preparing that. Modeling is such a small part, and because of that, you need the same sort of rigor. I would even say automation and just infrastructure that you need at the training and the serving at serving time, that you also need that with the data. So you don't need to just like store it. You need to have common definitions of it. You need to be able to add new ones to it, maybe combine new versions, and all of that should have metadata about that. So for example, where did this feature come from? What's the source? When was it created? Who created it? What's the range of values? These are things that you could have like documented somewhere, but it's just as important as the code in many ways. Like we can't. I think that's what I'm, trying to get at, is that it requires just as much care as like the predictions or any other step, and maybe even more, to be honest, because of how it affects your model. Like a good model is only as good as the data that you give it.
Hmm. And we have talked about this. I mentioned it to Kevin from Tecton when he was on, but I would love to see some feature statistics of like most used feature or most expensive feature. That kind of stuff would be awesome if you could build that into your feature store anytime
Yeah.
soon. We would love to see that.
Shout outs
Anyway,
to that.
moving on. We've got
Yeah.
metadata management, right? And we've also got the pipeline triggers. And
We're
that
gonna
will
just, I
cap it
think
off.
that, yeah, let's just cap it off with that. But I'm gonna kind of, metadata management is like its own topic. But the way I look at it is, in looking at the image, everything that's happening here needs to be recorded at a high level. So like you could look at running everything as an experimental run. And maybe a component within that experimental run is its own job. So maybe the data validation is its own job. And when I say job, you think like Kubernetes. It's going to be running on a cluster or some compute somewhere. And so you have a run that orchestrates all of these things, but you have metadata about that run. What pipeline was being used, what version, what data, what model, what parameters, what runs. You see what I'm saying? Like it's just everything that's going on here being recorded as well. That's huge, man, for reproducibility, because if I like, and I've done this, I've shot myself in the foot before where I'll like do all these runs, but I'm like not really keeping track of what I'm doing. And so I'm like trying to find this model artifact. I'm like, wait, is this the latest one or is that the latest one? Is this the one that had a bug in it? And I can get
Uh,
lost if I'm not, if
yeah.
I don't have a sense or like a registry or some sort of way to understand that. And usually, I mean, there's some nice tools now to make this easier, both open source and I think enterprise. But you could make a lot of this stuff from scratch, but it probably won't be as good as some of the other tools out there to help you enable metadata management. So like, you want to keep track of the important things so that if I needed to, I could rerun and reproduce every step of this.
Yeah.
So I can go back in time and like roll back to a previous version of something. Because I'm keeping track of this. And typically here, you're also going to have like monitoring as well. Like you're keeping track of what's going on, the different runs. And so maybe this is visible through a UI where you could see the metadata and everything that's going on with the runs. And then what's the last part? My screen is frozen.
The
There's
pipeline
metadata. Oh,
triggers.
triggers. Yeah. So triggers are cool, man, because this is like an event driven architecture sort of thing. So you have like, picture a function, some little thing that you put something in and out, and the output does something. And what you could do here is create many functions to do one thing, and it's like its own service. That's what like I'm thinking of GCP cloud functions or Lambda in AWS, where you just want it to do one like little unit of work, and it does it in a serverless fashion. And so you could do this to log metrics, and whenever it goes below some threshold, that's an event that you could write a function for to then say, when this happens, publish a topic about it. This has happened. And then maybe some other agent in this, you create an agent that triggers that event all over again. So you maybe have one that's monitoring, logging things, looking up at the metrics, maybe pushing them into Prometheus and Grafana regularly. Someone asked a question about this, about like logging. And then you have an event, you have a function that's like listening in on that, checking for that, and seeing when something happens bad or like wrong, whatever, you start it up again. So that could be like an automated sort of way to do this, but it could also be something as simple as a schedule. So let's just run it, as a cron job once every day. Maybe that's what maybe you're not exposing it as a REST API or model, but you have a scoring sort of architecture where you're making a bunch of predictions in batch, and then pushing them to some database. And then the next day, people use those values in the database. So you could do that with some sort of schedule, right? Maybe not like a cron job. And then I'm sure there's other smart, intelligent, solutions that people are thinking about there to also trigger these events. But that's basically the gist. Like here, not only do you have all this automation, but you have good monitoring of your process, and you're triggering things to happen in an automated fashion based off those events. So
Totally.
that's the gist, and that's level 0 and level 1.
Yeah. Quickly before we wrap this up, there are challenges with this one, and that's why there is a level 2, right? They went further. Google had to one up themselves and show us what level 2 would be. The challenges that you can get from this are when you're testing out new ideas, right? If you're continuously testing new ideas, this can get monotonous with the pipelines and having to, what I understand is deploy these pipelines manually. You want some kind of CI/CD system that's deploying the pipelines. Is that how I understand it? Is that correct?
Think so. Yeah, it's they want. I mean, that's one like thing that they're saying is a good practice in MLOps is CI and CD, which is a practice from DevOps, right? That's like something. I don't know if it's a cornerstone, but I don't know what the right word is.
But it's important.
Side note. Side note. It's I hate when I have a word in mind, but it's not coming to mind. But anyways, you get what I'm saying.
Yeah.
Yeah, I think you're right, man.
Cool. Well, this has been a lot better than yesterday. I'll tell you that much.
Oh yeah. Oh hell yeah. You guys hear Demetrius, man? He's killing it.
Oh, that's just because we did this yesterday and now
Nah,
I
just
know what
because
we're talking about. I think we should mess up the recording every time. The first
just so that we
time,
could do this, right?
yeah, so we can go over it a second time and I can pretend
This
like I
is
know what I'm
like
talking about.
our experimental environment, our production environment. This is a production environment. We got it right. We did a right now. We're definitely level 0, right?
Yeah.
We're manual as hell
We
right
are
now.
manually doing this for sure. But we're trying to bring you
Anyways,
all the good stuff. Please like,
yeah.
share, and comment all that. If you've made it
Yes.
this far, it would mean a lot to us. And the YouTube algorithm likes to see that, so they recommend it to more people. That's all we got today, David. Adios, amigo.
Peace.